Hey, everybody. Happy Wednesday afternoon. Thanks for making it out. My name is Nathan Tabor. I'm a senior product marketing manager here at AWS. And I'm joined by two exceptional people from one of our customers, Corteva. You guys want to introduce yourselves?
Hi, I'm Duke Tackle. I work on Randy's team.
Hi, I'm Randy. I manage a group of cloud engineers. So.
Awesome. Cool. And we're going to talk today about removing undifferentiated heavy lifting from CI/CD toolsets, and going to start a little bit with how AWS thinks about innovation and innovation in the cloud and building for innovation. And then we're going to map that into CI/CD and how Corteva takes advantage of CI/CD to innovate really quickly on behalf of their customers. So let's go ahead and get started. Awesome. So at Amazon, our leadership principles shape our approach to how we build for our customers. You've probably heard this a lot before, that we always start with customer obsession. So we listen to our customers, we listen to the problems that they're having, and we start with that and we work backwards to try and build the best solution that works for them. Not necessarily for our bottom line, but the solution that works for our customers. We take every opportunity we can to invent and simplify in the way that we build. We find new routes for innovation and look for new ideas everywhere. And a lot of those ideas actually come from our customers, as you can imagine. And third, we have a bias for action. So we believe strongly that speed matters in business, and that when you move quickly, you can actually deliver a lot of innovation with less risk than you may think. And we highly value calculated risk-taking in the way that we make decisions. So it really comes down to that we see our customers, in the words of Jeff Bezos, as invited guests to the party, and we're the hosts. And obviously, we're here at reInvent, where AWS is the host for all of you. And that's really exciting for us because people like me come to work every day, whether it's in an office building or in a convention center, to make every aspect of our customer experience just a little bit better. So this is all well and good, but you're not here to hear about what Jeff has to say about this. You're here to learn a little bit about how do we actually do this. How do we transform ideas and customer pain into innovation, and how does that map into the things that Corteva Agriscience is doing for their customers? So we see three characteristics to being able to innovate really quickly. First, we listen. We work backwards like we had in the last slide. Second, we experiment. We take risks, and we try things out. And third, we iterate. As we see what works and what doesn't, we make quick decisions to move forward and then test to the next, listen to what the feedback is, and test in the next round of iterations. So really what this comes down to when you're building digital systems is you need the ability to experiment really quickly. It's actually not super hard to go out and listen to your customers. A lot of you probably do this today. And it's also not super hard to necessarily actually iterate on something when you want to try a new idea, or you know when something's going to work. The problem is that you don't always know what's going to work. And the things that work or don't work are not necessarily intuitive. And so we need to build for rapid experimentation. It's that trying things out, which is the sticky point, both in the services we provide and the way that you build software and deliver it, that often trips people up. So we have to try a lot of experiments, and we have to eliminate the collateral damage from failed experiments, because that collateral damage, sometimes people refer to that as tech debt. You may have heard that. That collateral damage can really trip you up in the long run. So what are kind of the principles that we're thinking about as we build for rapid experimentation? What we try to do is we simplify infrastructure management. We componentize our applications. We standardize and automate operations. We work to improve application performance. We create a culture of innovation everywhere we can. And we update applications and infrastructure quickly so that we can ensure customer trust. You may look at some of these things and say, hey, this is really aligned to some things that we already do or some things that I've already seen, especially if you're in the DevOps world or have thought about the DevOps world really deeply. And we call this modern application development. So applying all these principles helps you iterate really quickly and build and deliver value faster for your customers. And at Amazon, we actually believe that we should architect this not just into the way that we work, but also into the systems and the services that we deliver for our customers. So if you look closely at a lot of the launches, or most of the launches that are happening this week at re:Invent, all the new stuff that's been announced, you'll actually see a lot of these threads running through all of these launches. Every launch may not, every new thing we announce may not cover all of these components, but it probably covers one or two or maybe even more. Because we believe that we want to enable our customers to build modern applications and deliver value faster on behalf of their customers. So these are kind of the three pillars in the ways that Amazon builds and runs our modern applications. First, we build everything as microservices whenever we can. Componentizing things via services lets you innovate really quickly, because when you make a change, the impact of that change is much smaller. We believe in products and not projects. So when we build something, we run it. Finally, when we deliver those microservices, we do it as much as possible using serverless compute and database resources. So we try to eliminate that undifferentiated heavy lifting among our teams of provisioning and managing infrastructure. We build as many automated systems, and we test those systems so that we know that we can set something up and run it, and we don't have to worry about all the infrastructure underneath. This serverless infrastructure needs to scale by unit of consumption, and you should really only pay for the value that you receive. You really shouldn't be paying for idle resources that are sitting there not doing any work. And then finally, what's really important with serverless is to have built-in availability and fault tolerance. So we set up and build serverless systems internally to build AWS services, and we also have serverless systems like Lambda and Fargate and Aurora Serverless for our customers to use for their applications. And then third, DevOps. The DevOps culture is actually extremely important to making microservices and serverless work. If you don't give the authority and the responsibility to the teams that are actually building and running these services, then you usually end up with a place where everything is bottlenecked through a central location, and it can't be, it hampers your ability to quickly innovate. And so we believe in giving autonomy and power to the teams that are building microservices and running them on serverless architectures in order for them to iterate and deliver value quickly on behalf of our customers and the organization. So what we're seeing is that companies in every segment are building modern applications. Startups, from small startups to large enterprises, virtually every industry, B2B, B2C, and all kinds of verticals. So some of those verticals are things like banking. We talked a little bit about today in Andy's keynote, automobile racing. We see things with social media, all the places you might expect. A vertical that you may not expect to have a lot of innovation in the digital landscape is agriculture. And that's why we have Corteva here today to talk a little bit about what they're doing to build modern applications.
Agriculture. It sustains us all and drives what we do. Growing food for tomorrow, and growing tomorrow itself. Hand in hand, enriching lives, never settling, ever. We're growing progress by making every crop, field, farm stronger. We're growing progress by being the most innovative, most inclusive, most open agriculture company in the world. And our new role will bring more innovators to the table. Employees, producers, consumers, the best of the best. We'll work together, not just to meet standards, but to set them. We are Corteva Agriscience, and this is the company we're creating. We're one company. We're leading the way. We're growing progress. Introducing Corteva Agriscience.
Mic test. So my name's Randy. I have the privilege of working with a group of cloud engineers with Corteva. I've been there a relatively short time. It'll be a year in January. So we're learning, I'm learning, and it's a growing process that we're doing together. Pretty exciting. But the reason you're here is this is a dev session, so I'm going to try to burn through this as fast as I can to get you guys to the meat and the heart of really what we're talking about with undifferentiated heavy lifting and how we applied it to Corteva and into our cloud engineering team. But we believe this, you know, what Dr. Vogel says, you know, spending money on heavy lifting, taking the heavy lifting out of our hands. We work in our cloud engineering team to help developers actualize their code into AWS. We'd rather focus on that than focus on the services around that and the things around that to enable us to do that. So we're specifically talking here about AWS code or AWS developer tools and that entire suite that enables us to do that. So managed services. We chose that route because there's a lot of things that we could have done. There's a lot of things that we could use. The ship is so large we can still use multiple faucets and tools and avenues into there. This is just kind of our story. It's not right or wrong for any organizations, but this is what we found when faced with some of the issues that we have. So one thing we really like about the managed services is, you know, everybody hears it, it's easy to implement, right? Another one is, as we're getting ready to build this new company, FTE involvement is critical, and moving people into the right roles and doing the right functions is critical. So a managed service, we have little to zero FTE involvement in that at all. And like Nate said when he was up here, we pay for what we use. We don't have things spinning idly that we have to pay for. So how did we travel down this path, and what journey did we go on? We're still doing it, but what did we do to choose the services? We looked around. Did they exist? Did the service exist? Is there something that's going to replace this lifting that we're doing? And then we had expectations, as everybody does, or requirements of the service. Did it have a pretty UI, CLI only? What were the features, right? And what percentage of those needs were met? So we looked at the things, and we chose as a team that 80% of the features or the expectations that we had, if we met them, we would go with that service. So kind of what helped us drive those decisions was the organization and the business, right? So some of the things that drove our decisions was a research and facility that had a lot of data. We're seeing a large amount of data from genomic sequencers to hyperspectral imaging to UAS drone flight images, all of that being fed into our system, all of it being different, all of it being a different size and a different requirement. We needed to focus on those things rather than focus on a deployment tool. Another thing it had to be is flexible and scalable. And we needed to be able to rapidly change things, but it needed to infinitely scale for all of those data types. And it needed to be operationally excellent, right? We didn't need to spend time thinking about our CI/CD tool. We needed it to work when we said go. And last, it needed to be easily adoptable. We say that in kind of almost in jest, but we're still struggling. This is part of our journey of the adoption rate, right? So what we've observed through this transition, through this last 8-9 months, we've seen very low cost. This managed service is very low cost. It's very beneficial to us. The entire AWS developer tools we're spending less than $200 a month on for, you know, right around 300 jobs. Zero maintenance. We don't patch this, right? AWS does for us. There's zero downtime that we've experienced, but we go with what the provider SLA is, and so we're fortunate to see that the uptime on the AWS services has been stellar. And then the faster realization. We've used a lot of number of the CI/CD tools, and a lot of those required a lot of work, a lot of massaging, a lot of scripts, and we've actually seen from months to days actualization transitioning from some of our legacy tools to CodePipeline, CodeCommit, code deploy from months to days deploying these applications in the software. If you're familiar with CloudFormation, it's a pretty trivial implementation. Once you have it in a static CloudFormation template, you can reuse it throughout your environment, right? Rapid change, deploy, redeploy. All we're doing is changing a CloudFormation template. And now, finally, context shift. There's none for developers. Now they can focus on code. When they commit to their source, it gets an action is taken, right? So now they're continually working on code instead of the nuances of what their CI/CD tool does, right? So, but we've also learned some things along this journey, right? There's a very slow adoption rate right now. We're a team that loves this tool, and we use it quite a bit, and more we're seeing more of our developers adopt it, but we're still traveling. We're still in that journey. We've got a lot of attitudes of not built here, right? Even though it's open source or crowdsourced software, a lot of the CI/CD tools, there's still an attitude that we've got to do that and we've got to maintain that. We've got to know what it's doing all the time. And then we get a little bit of inexperience with being relatively new to the cloud and relatively new to the AWS and evangelizing it, right? So, and then there's a lot of short gains, the myopic view, instead of looking at it what it's going to be in 3 years, 4 years, 2 years even, right? So we've also found that in-house options are expensive, cost comparative to the services running for other CI/CD tools and the infrastructure to support it versus AWS developer tools is quite a bit more expensive, as well as the FTE commitment that you have to maintain that. And really, cloud is hard, tongue-in-cheek, but we're still evangelizing, we're still teaching, we're still moving through that journey. So how do we continue? What do we do from here? Where are we going? We've actively started doing more guidance and evangelism of the product and the suite, how to use it, helping them actualize it. What Nate talked about, what Dr. Vogel's talked about, continued feature request. Make them known to AWS. You're not going to be treated like this. They will respond. We found that out just, our small team making requests. We want this in here. We want this in here. They listened. They listened actively, and they fulfilled a lot of those requests. So, and results, right? Start small, get other teams involved, get other devs involved, and once those things start to build, those other teams are your evangelists for it. They help drive adoption throughout the organization. So with that, I'd like to introduce Duke. He's going to do our tech talk and demo, and I appreciate your time. If you've got questions after this, we probably won't have time for a Q&A session, but if you gather at the side of the stage, we'll be more than happy to hang out, tell you a little bit more about our story, a little bit more about what we do, answer any of the technical questions, talk to you about where the code's available at, and any other issues we might have. Thanks.
Thanks, Randy. First, thank you for bringing me along on this adventure. And Nate bailed out, but I'd like to thank him for bringing us both along to talk about this stuff that we're really passionate about. And of course, thank you for spending some time with us to hear us prattle on about this stuff. Which one is this one? All right. So we take projects into our backlog, and one day a problem came into our backlog. And I'm going to tell you a story about how we used two services with the help of one of our favorite services, CloudFormation, to solve that service, or solve that problem. The problem we had was to implement a highly available genetic analysis API for genetic sequencing data that was coming off some sequencers in labs all over the world. So what were the constraints and the requirements of this problem that came into our backlog? Well, the constraint was there was already some C++ written that could be compiled into a library to analyze this genetic sequencing data that was coming off these sequencers. And it had been sort of wrapped up in a Python wheel to expose as a RESTful API. And then that wheel had been sort of put into a container. So what we had was like a handcrafted labor of love proof of concept. It kind of worked, but we had to really put it into production. Going back to the title of the session, removing undifferentiated heavy lifting, both Nate and Randy have talked about the idea of removing undifferentiated heavy lifting as sort of a platitude. In this particular project, the project sponsor, the project owner, had been burned by a previous project team trying to weaponize, productionize this particular application. So I really, really needed to do all I could do to bring this thing to the production environment, but no more. So I needed to find a set of services that AWS offered to put that back on the floor and do it well and make this guy happy, because he was not the easiest guy in the world to please. So we had to containerize the solution, which that constraint comes in that we already had that handcrafted labor of love container pushed into a local on-prem Docker repo. It had to be CI/CD hooked up to it, because the development team was still iterating through the algorithms in that C++ library I talked about. So when they pushed code on their repo, we needed to get it into the dev environment so that they could see if it was working or not. And when that push happened, they needed to be aware that the build was a failure or a success. It was usually a success. So we integrated our code pipelines with our Slack-like tool called Mattermost, and they were alerted to the success or failure of what they had just pushed. So this is a rather well-defined small project. You know, talking about a big, gigantic set of systems for this sort of talk wouldn't be appropriate. So this problem, here is the complete solution of this. At the heart of it is the Polaris Fargate cluster. Polaris was the code name of the product. So we had a Fargate cluster that used the image that I created in the code pipeline that exposed the RESTful API that was that C++ code that I talked about. It was fronted by an application load balancer that we put in our private subnets, and it was accessed over our corporate VPN, because this was and never will be a publicly accessible API. And as most meaningful applications, we needed some data store, and I removed more undifferentiated heavy lifting by calling my friend Aurora in it, so we had a database cluster for that. So that is, in broad strokes, the problem that we solved. And now I'm going to talk a little bit about where we solved it, the account structure for what we use. So this is a very, very high-level orbital view of our account structure. We use a hub and spoke topology. We have an account in the middle that we call the utility account. The utility account is where the IAM users authenticate and then assume roles into all the other accounts. We keep all the CodeCommit repos, all the ECR repos, you know, the stuff that can be centralized and then shared out with permissions to other accounts, we keep in that single account. We do have one account we call the sandbox account. That's a playground for developers to go futzing around with, as developers will futz around. They go mash around in the console and explore new services, as they probably will be doing a lot next week, because there's been a lot announced this week. So for the code pipeline, though, the first target environment is our dev account. And when I say account and environment, we have one account per environment. So the dev account is the dev environment. So as you would expect, the next one is a QA environment made in the QA account. It's the second CI/CD target. For this particular application, it was the user acceptance environment. So the development team was looking at the code they just released in the development environment. The project sponsor and the scientists were looking at what was coming out of the user acceptance environment when they pushed test data into it. So as with many applications, prod is the end of the line. The code pipeline moved from QA to prod. However, in this particular case, since the project sponsor had been burned by the previous team, he really wanted to be in control of when things went to prod. So we had to put a deployment gate in between QA and production. That was once again done with some integration with our Slack tool that we use, Mattermost. And it would just show up in the project channel, and they would approve or reject the change. So all of our accounts, all of our environments, we have built with CloudFormation. And it's all the same CloudFormation. We make heavy use of exports and imports. So the environments are layers of CloudFormation stacks, the bottom being the VPC, all the way up to the application layer for the CloudFormation stacks. Like I say, there's a common template for all of the environments and all the applications. Where we need to differentiate between the different environments or accounts, we put that into a different config file. So it is our custom to make a config directory, and in that directory you'll find like a sandbox INI file, and a dev INI file, ... and a prod INI file. So here we see an example of one of those INI files that would be fed into one of the environments. And then that INI file is put through our CloudFormation tool that we've written to make the stacks in the various environments as the things are deployed. So calling back to the requirements and the constraints of the project, I said we needed the stuff to be completely defined in code, and that wasn't just for this project. It's a mantra of our team. We have a very strong bias for CloudFormation. We're big fans of the service, but sometimes it isn't fit to purpose. So then you can almost always solve the next level of problems with Boto 3. So we write a lot of Boto 3 utilities in libraries, and some of them are published to our internal artifact store. Some of them are published out to PyPy, and we'll be using that later on when I do a deep dive into a real example. Like some of the tools that we've developed and put out at PyPy are Stackility, which is the CloudFormation tool, which I alluded to a moment ago. So finally, on this slide, we see Sandbox is the only really accepted use for the console. Everywhere else, we need to be deploying stuff with code through CI/CD pipelines. Once again, calling back to the requirements and constraints of this project, it had to be containerized. Containers are cliche, and they're cliche for a reason, and I won't bore you with that. I mean, everybody here probably knows the value and benefits of running containers. Our images are built and stored in the central account, which we call the utility account, and then pushed into ECR repos there. And then those same images are promoted through the SDLC to see stuff actually realized in the different accounts with the same exact images from the same account. This particular solution, we used ECS Fargate, and because we are big, gigantic, huge fans of Fargate. I wasn't able to come to reInvent last year, but I did watch the keynote where Fargate was announced, and I was really excited, going, that is a really cool facility. I really want to get my hands on that. So I went back to my desk out of the conference room after seeing the keynote, and I bashed away on a CloudFormation template for a Fargate cluster. And by the end of the day, I had our first Fargate cluster. It wasn't doing anything meaningful, but we had one up with CloudFormation and all that. And I went home and I felt pretty good. I came back the next day, and my colleague that was sitting next to me had heard me prattling on about this new service they announced yesterday. And he said, wait a second, I've got a problem I could use that for. So he checked out the code, futzed around with it for 4 or 5 hours. And by that afternoon, he had a Fargate cluster solving problems for data scientists just a little more than 24 hours after that thing had been announced. And that's really a speed of innovation that's really, really cool. So, as you can probably tell by the title of this session, we are big, gigantic, huge fans of CodePipeline. One of the 2 reasons why we really like CodePipeline is that we can implement it, maintain it with one of our other favorite tools, CloudFormation. So all of our code pipelines are made with CloudFormation, and I'm going to go into an example of that in a little bit. Code build, CodePipeline's little brother, is a very, very powerful and flexible tool. I haven't run against a problem that I can't solve with it yet. So now let's take a look at the pipeline itself. So a pipeline is always initiated in our use case, and I should say this is just the way we use it. There are obviously many other ways that this suite could be used, but this use case that I'm walking through now, it serves very well for the problems that we're solving. So when stuff is pushed into our on-prem Bitbucket, our developers like Bitbucket, and that's fine. There's a plugin installed in the on-prem Bitbucket that mirrors that to a corresponding CodeCommit repo. And then once the CodeCommit repo takes that, then it initiates our code pipeline process. And as I say code pipeline, for all intents and purposes, you could look at code pipeline in our use case as just a big box to put code build projects. So once you fire up a pipeline, then the real work begins in divisions, which are called stages. And stages have one-to-many actions. So the first stage in this pipeline was where we compiled the C++ code, wrapped it in a wheel, and published that wheel to our Artifactory. The next stage was taking that wheel out of the Artifactory and doing a Docker build and publishing the resulting image into ECR in that centralized account. Then finally, the fun begins by taking that image that we just published to ECR in the central account and making a Fargate cluster with CloudFormation in the development account, or the in the QA, the development account. And then finally, after they had accepted the change that came into the Mattermost channel, that same image was deployed to production and would take data from the sequencers, as was the problem's goal. So that's, in broad strokes, the problem that I solved, and obviously, I mean, there's secret sauce in there, and I can't actually show any of that stuff. But I have developed a pretty detailed example and put it on GitHub, and you'll see later the Git coordinates for that. So if you're interested in CodePipeline and Fargate, you can pull that down, tweak the config files, and have a go at it. So as I'm learning new stuff, one of the things that really, really frustrate me are death by snippets. And the person writing these snippets, they assume you know where to put these snippets in the giant collage, which will form the eventual solution. Well, not this one. This one has CloudFormation all the way from the VPC through the Fargate cluster. So there's CloudFormation for, as I say, the VPC. We, as a standard, have a deploy role for where the code pipeline runs in, and that is the thing that's permissioned to provision your assets as needed. The project also has a run role, so that will actually allow it to use the services that it needs. So I've included CloudFormation templates to build those two roles. And of course, CloudFormation template for a code pipeline that actually builds the Fargate cluster. So since time is relatively short, I'm only talking about the CloudFormation to build the code pipeline here in this talk. So here in this slide, we see the two views onto a code pipeline. And the one on the left is the CloudFormation resources that get built to realize this pipeline. And on the right is the code pipeline view, where you see the stages with the needed transitions. So if we walk through the CloudFormation view, we see that the resources that are built are the code pipeline, a code build project that is going to build the wheel and publish it to some crude artifact store. In this case, it's S3, since I don't have an artifactory. The next one is a code build project that builds the image and pushes it to an ECR. And finally, there's a code build project that builds and deploys the Fargate cluster. So the anatomy of most of my pipelines, I have 2 to many stages, and each stage has 1 to many actions. And actions are where code build actually does its stuff. So inside of a stage, you can either do actions in parallel or serially. To do them serially, you can specify a run order to say, I need this one to run first, and this one to run second, third, fourth, ... So here's a snippet of CloudFormation that you'll find in that repo that will build the first code build project. And I want to call out 4 things about this code build project. The first is the IAM role. So this is where the deploy role is called into play. So it allows the provisioning or whatever has to happen in this particular code build step. The next is you specify an image for this code build project. And there is the real power of code build, in my estimation. Amazon has a bunch of curated images that you can use, and you can tell what's in those images. They have them in GitHub. You'll almost certainly be able to find one to solve the problem that you're trying to build. I mean, they've got Python 2, Python 3, Go, Java, Node.js, a whole bunch of stuff. So you'll almost certainly be able to find one. But if you can't, you can build your own, like I had to for the Polaris project, since I had a very special compiler and libraries that needed to be installed. And interestingly, that image that I used in that code build was built with another code pipeline when I iterated through building the image. So the next thing I want to point out about specifying a code build project are the environment variables. So the environment variables are what inform the end-of-the-line script, what it actually needs to do the work of this deploy job. And finally, the description of what happens in the pipeline is in a build spec file. I use one build spec file for all the code build projects, so that that is one and only one moving part for that job. So here's the other image build, code build project. Very, very similar, the same 4 bits. The major thing that's changed here is there's an environment variable called mode. So when we get to the end, the build script will be able to tell what to do in the deployment process by examining that mode variable. And notice again, we still have the deployment build spec file. If you don't specify the build spec file in a code build project, it will assume that you have a build spec file in the root of your repo. So shifting to a stage context, this is the snippet of code that you'll pretty much copy and paste around to every pipeline. This is the stuff that allows the pipeline to get the sources out of CodeCommit or whatever code repository you're using. So, I mean, I copied this around. I wrote this once months ago. So staying in a stage context here, we see these two things. Remember, stages are comprised of one-to-many actions. And since this stage is about building and publishing that wheel in that image, I need the wheel to be built and published first, and then the image. So I've specified the run order here. And then the code build project that we built earlier, the last two steps, are actually called out. So this action refers to the wheel project, and then the next action calls on the image project. So if for some reason, like if I'm building a bunch of IAM roles, I'll omit the run order so I can build all of the IAM roles at once. So we can get that done very, very quickly if you run those things in parallel. So now we're changing back to the code build view of things. So this is the last code build project. This is the code build project that actually deploys the Fargate cluster with the use of a CloudFormation template. Once again, this has the same 4 bits. You specify the IAM role that it's going to run in. You specify the container that's going to do the work. You specify all the environment variables, noting again that the mode here in this case is deploy Fargate. And we're using the same build spec file. So the last stage of getting this thing done is actually running the CloudFormation stack, and we do that in this last action that uses the last Fargate deploy project that we just made. So I've called out the build spec file. Now we can look at what that actually looks like. So a build spec file can have all of these phases: the install phase, the pre-build phase, the build phase, and the post-build phase. I usually, I always have something to do in the build phase. Sometimes I skip the install phase or the pre-build phase or the post-build. In this case, in this example, I'm installing in the install phase the requirements, the tools that I need to do the work. And then finally, in the build phase, I'm specifying that the build sh file is the complete build instruction set for this pipeline. So now we can take a look at the build file. So this is just a little bit of a shell script. This is where the environment variables actually meet the real world to do the work. And you'll notice we're just saying if the mode is build wheel, then we Python set up bdist wheel and then shove that wheel into an artifact store. In the case of this very simple example, I'm shoving it into an S3 bucket. If the mode is build image, I do a Docker build on the image and shove it into an ECR after I tag it. And if the mode is deploy Fargate, I call our friend Stackility to actually make the stack that implements the Fargate cluster, and then does a little bit of stuff to tell Fargate, hey, use the new stuff, don't just use the old stuff. So that's what I have. I hope you guys are interested to go see what this example can do for you. Randy and I are going to be up here for as long as you guys want to talk to us about this stuff, because we're enthusiastic about code build and Fargate, and a bunch of other services, but those two specifically. So thank you for your time.
Thankful you guys came out. We are passionate about code, passionate about deploying, passionate about removing a lot of heavy lifting on the front side of the things that we're doing, and creating a number of repeatable processes. Now Duke has gone ahead and put all this code together. It's in a GitHub repo. You can go pull it down, play with it, and do whatever you want to with it. We're available. Look us up on LinkedIn or find us somewhere on the interwebs. But any questions you have that could kind of steer us towards evangelizing this tool and using this tool, we'd love to help you out there. We're still in the middle of our journey, and so we don't have all the answers. This is kind of this is our story. This is how we made it work. This is what's working for us. We're shifting as we move through this. We're making changes, but we're very passionate about managed services. Again, very passionate about what AWS is doing with managed services, and allowing us to focus on what the business really needs, and that's managing the data, managing the applications, helping developers get resources into AWS to be productive. So appreciate you guys' time. Thanks.